Sorry about that. Somebody just rung the phone then. Okay, so these will be drivers, and then these things here, if you remember the symbol from the data sheet, these are the MOSFETs, and we see up one above the coil, one below the coil. What this chip basically does, we can go into this in much more detail later, but what this chip does is it turns on each of these in turn. This is your Gatling gun, bam, 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 bam. In our case, bam, 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 bam. There's two of them. When it turns the chip on, the first thing that happens is this driver turns on this MOSFET. So the 12 volt comes through this MOSFET. It's like a switch. It's now closed. Comes through the switch, through the coil, and into the GPU, this capacitor. When it flows through the coil, what the coil does, it's basically a coil. It says it's a coil. It's wire wrapped around and around a magnetic bobbin, I suppose you can call it. It could be metal, it could be ferrite, but it's wrapped around a core or a bobbin. So when that turns on, this MOSFET, the power starts to flow down here. But the way an inductor, a coil, works, it will resist a sudden change in direction of flow. So all of a sudden, this had 0 volts and now it's got 12. This is on. So the power tries to rush through here into the GPU, but this holds it back. And while it's holding it back, it's magnetizing the core. So the power starts coming through. This is increasing more and more magnetized, and power is coming through to here. And what this chip can do is it can measure the voltage here. In fact, you can see it if you follow this wire. Voltage sense. So it measures the voltage here. So when there's enough voltage, 1 volt, 1.1, whatever it wants, it turns this FET off. And then it goes to the next one. But when this FET turns off, this now is magnetized, yeah? So we need to demagnetize this before we can use it again. So when it turns this FET off, it turns this FET on. That then shorts this end of the coil to ground, and it discharges the magnetism. It demagnetizes it. Okay. What happens then is this chip switches this one on. Gets the pulse, this switches on, turns this transistor on. Same thing happens, flows through the coil into the GPU. This builds up its magnetic field. It's resisting the flow of electricity, and when it sees enough here, it switches this one off and switches this on. Demagnetizes the coil, and then it goes back to the first one. So alternately, this coil is feeding power into here, and when it builds up to a certain point, the controller switches that off, switches this on, and demagnetizes the coil. Then they say next with this one, and backwards and forwards, backwards and forwards, backwards and forwards. And the reason it's using more than one coil is because, first of all, these will get hot. Okay, while they're switching, they get hot. So it's to effectively, if you like, it's sharing the load between this one and this one. There's probably other reasons. There's probably you can only switch at a certain speed, whereas when you've got 2, you can do it twice as fast if you like, and 4, you'll share the load into 4 and do it 4 times as fast. But that's how it basically works. So the voltage here will depend on what's coming through these coils, and how it controls that. This effectively alters the width of the pulse, the amount of time it turns this on for. Can you see? The longer this is turned on for, the more power gets through to here, the higher the voltage will be. That makes sense, yeah? And so on. So that's how that circuit works. Now, what we had on our board, if you remember, we could find the PX3544. We could find these MOSFETs, and we found a funny little chip that we had some funny part number for. What was it now? We looked it up. 11AD FPKJ, and we couldn't find what that was. But if you notice on this design, actually it tells us here what it is. It's a PX3511. So I went in and searched for the datasheet for that one. And what do we have it? It tells us somewhere, it's a synchronous rectified buck MOSFET driver. And that actually shows us what that chip is and what it does. It takes a pulse in, pulse width modulation. That means it can vary the width of the pulse. That's how it controls the voltage. And when it sees the pulse, first of all it turns on the one FET, then it turns on the other FET, and so on. That's what this is doing. So I've shown you that on there. Let's now go to the bench and let's have a look to see how that compares with what we actually have on our board. We need to go to Deskcam. Switch the Deskcam on. Okay. So this is a printout of what we've just looked at. Okay. This is the circuit board. Let's try and put it so we can actually see both. That's one of the graphics cards. I've also printed out, what do we have here? That one. This is for the FETs. These FETs, 4841, 4835, those are these FETs we see here. Now you'll say straight away, say, hang on, there's 3 there. And on that diagram, there's only 2. Yeah, there is, isn't there? What you very often find is that this bottom one is actually 2 wired in parallel. So what you often find is there's another one wired from here, another FET, draw the little thing in, wired to ground. Yeah, that isn't going to work, is it? Let's draw it to another one. So you'll often find there's another one. Let's draw it the other way. Wired from here, a FET, and then from here, exactly the same as the other one, it goes to ground. And then there's a connection from the gate here to the gate here, and that can turn on. When it turns on one, it turns on both on. And I believe, I mean, some circuit designer is going to tell me, Rich, you're not quite right here, but I believe that the mounter, this is so it can discharge, it can demagnetize this coil much faster than it could magnetize it, so it's ready to be used again. That's why I think they use 2, so twice as much current can flow through, and that's why. So you'll very, very often see this. That will show you 1, and when you look on your board, you've got 2. But let's look how this is. You've got 12 volts coming into the 1 FET, yeah? What is it? This is what we call the high side. It's called the high side because the high voltage, 12 volt, comes in here, yeah? This one, or the 2, this is what we call the low side. If there's 2 together, I think you'll always, somebody's going to tell me I'm wrong, but I think you'll always find them on the low side. The junction between the 2 is connected to the coil, and the other side of the coil goes to the GPU. And we can look at this, and we can actually see this on our board. So let's actually have a look to see what we have. And there is a point to this, by the way, if you're thinking, why you get into this detail. There's something important to learn here, so let's continue a little bit, okay. So there's the meter. So let's look at the first one. There's 2 phases here, so let's have a look at the first one. So first one, top of the FET. I can show you. This is how the FET is. If let's put it the same way up as my diagram. Okay. You've got the drain. Oh, come on. You got the drain and the source. Yeah, that's the 12 volts. This is the 0 volts, and this is the gate. This is what turns it on, and that should match what we have on our board. So let's see now. Try and keep some focus on this. Okay. So we need to start with the 12 volts. That's where we start. 12 volts, yeah? So your 12 volts coming in, and according to our diagram, that should go to the first FET. Yeah, it is. That is connected to there. We can see that. Then, let's just go back to our diagram again. So let's remind ourselves. That was the high side FET that's coming in. The junction of the 2 FETs goes to the coil. Yep. So that's the source from one and the drain from the other one. The junction will be in between them. So here, we expect this to go to the coil. That's the top of that FET and the bottom of this one. Yeah. So this point here, that connects to that and connects to the coil. That is where we see here, yeah? And then the other FET should go to ground. Sorry, the other side of the FET, the low side FET, should go to ground. So we now connect to ground, and let's have a look. Yep, that's one, and that's the other. So that's how that circuit is. This little thing here, that's the controller chip that drives, first switches this one, then switches that one, then this one, then that one, and so on. And we can find the same on the other one. So 12 volt comes in. Mustn't be on there. No, I am on there. Oh, you see how here, obviously this board's designed at some point maybe for a different GPU to have a third one here, yeah? That's unpopulated. But now that's interesting. According to our diagram, there must be 12 volts on here, and there isn't. Well, it's not connecting to the 12 volts, put it that way. Let's have a look on the other board. See, because we're seeing something a little bit strange there. Let's have a look on the other one. 12 volts coming in here. On the unpopulated one. Nothing on that one. I think, yeah, I know what's going on here. This is the sort of thing that can fool you when you're not very experienced. I'm pretty sure I know what's going on. Let me check first, and if I'm right, I'll tell you. I'll tell you what I found out. Yeah, I'm right. Okay, so this board, there's more than one place that 12 volts can come on the board. Okay, the 12 volts can come from the connector up here, but there are graphic cards that don't have an extra connector, they just plug into the PCI. And thinking about it, actually, there are graphic cards that when you don't plug a 12 volt into here, it will put a little bit of text up on the screen in red saying you've not connected the 12 volts E80X connector. And to do that, this must have some power to put that on the screen, and it's got to be coming from somewhere, yeah? That's logical. And where is it going to be coming from? Well, if it ain't coming from here, the only other place it can come from is here. And I mentioned this before. On here, coming in is 12 volts and 3 volts. And the 12 volts is on the first 3 pins. And when we go from there, there's our 12 volt supply for this one. So this regulator circuit is being powered from here, which I remember looking up, this can power something like 60 watts or 70 watts. There's some amount it can power. That one's being powered from here, and this one's being powered from here. So no, it's not faulty. That's just the way this is designed. That's quite reasonable. So that's the sort of thing that you can find when you don't have much experience, and you think, oh my god, what's wrong with it? And then it turns out there's nothing wrong with it. So that's that one. So we know where the 12 volt comes from now. Bottom end of this FET should connect to the top of these ones. Make sure I can actually get it. Yeah. Yeah. And yeah, to the coil. So that's right. And then you remember the bottom end of the other one, the low side, will connect to ground. Yeah. Would help, wouldn't it, if I keep this meter in where you can see it. Hopefully you can hear it though. Both to ground, from the coil, bottom side of this one, top side of these two. So both of those circuits check out. And while we're at it, you see this one here, this also has 3. Sorry, you see this one here, this also has 3 MOSFETs, 1, 2, 3. And I suspect we can probably measure this one as well and find that the 12 volt comes in somewhere. If it doesn't, oh, I have to make a good connection. Right, so we found it. So this is just upside down, if you like. This is the 12 volts coming in, and it comes from the PCI. The other side of this one, I'm pretty sure we'll find it's connected. Let's find the ground. That's not ground, that's reading 50 ohms. That's the ground side. So the coil is going to go to both sides of these and to that side of that. So you see, it's just the other way up, but that is the same. And you're going to find this exactly the same sort of circuit all over the place on motherboards, on graphics cards, and on such like. So I hope you learned something from that. I'm just going to tell you one more thing, and this is quite important. Let's just go back to our diagram. Now, you know I said to you, this chip drives this one, and the first thing it does is switches this MOSFET on, okay? And puts power, magnetizes this coil, and some of the power is coming through into here. Afterwards, it switches this one on and demagnetizes it, and so on and so on. Right. These high side MOSFETs, let's have a think what can go wrong with this circuit, or what's the most likely thing. I'll tell you what can go wrong with this circuit. First one is that this chip isn't giving any drive, it's not switching anything. It probably isn't faulty, this isn't being enabled. There's ways we can look at the datasheet and figure out what conditions are required here for this to be working. So that's one thing, this may be just not driving anything. If that happens, you'll get no voltage here because it's not being driven. The second thing that can go wrong with it is one of these high side MOSFETs goes short circuit. What happens now, the instant that goes short circuit, this 12 volts comes down through this coil, which is magnetizing into here. This coil can only magnetize to a certain point. So the magnetic field will build up till it reaches the point where it can no longer magnetize any further. And that point is called saturation. When this coil saturates, effectively it's no longer an inductor, it's just a piece of wire. And now the 12 volts come straight down this piece of wire straight into here. One or two things is going to happen here now. And it's kind of like who wins the race. Either this sense chip here is going to see that there's too much voltage on here. Yeah? And it could, depending on the controller, it could be designed in such a way that it has like a safety net. So when there's too much voltage on here, it assumes that there's a fault here and it switches these on. Yep, switches the low sides on. What happens now is the power, 12 volts coming in here, will be short circuited here from ground to ground. It'll probably blow a fuse, something's going to go pop. There's quite often where the power comes into the board, there's a fuse, and it'll blow the fuse. And hopefully, it will save your GPU. The other thing that can happen is this doesn't react fast enough. The voltage on here goes way above 1 volt, 2, 3, 5, 12 volts, and this GPU burns out. And the chances of that happening, somebody on one of the forums said to me, in his experience, it's about 50-50 whether a GPU can survive a short circuit high side FET. It's about 50-50, and the more modern the GPU, the more powerful the GPU, the less likely to survive. A bit like an engine, you know, I don't know if you know this, but with a car engine, if the cam belt snaps, the higher the performance of the engine, the closer the tolerances, and the more likely you are to smash the valves and bend the valves. A lower performance engine is more likely to survive that instance. So, one of the worst things that can happen here is these one or more high side FETs go short, and it blows the GPU. Now let's see what happens if a low side FET goes short. If a low side FET goes short, when this one turns on, no voltage can go down here because it's got a short circuit here. So what happens if you have a short circuit on the low side FETs, generally, is that it may blow the fuse. Remember, this is switching on and off quite rapidly. It may just draw a lot of power. but the chances are your GPU is safe. So that's the two things that are most likely to go wrong. And this not only applies to graphics cards, it also applies to processors, CPUs, or motherboards that have a very similar setup. On the motherboard, it's much easier because you can change the CPU, and you can either blow another one up, or you have the sense to find out what went wrong before you change it. With a graphics card, you can change this GPU. I have the equipment here to do it, and I'll show you how to do it. Whether or not you can get another one is another matter. There's one third possibility actually here. It may be high side short, yeah? Shorted FET, high side. Too much voltage here. This capacitor, and this won't be one capacitor, this will be whole banks of capacitors. Remember all these and all these? Yeah? And there was some these tantalum capacitors. That capacitor won't be one capacitor. It's all of those, yeah. And these have a maximum voltage rating as well. And if you're really lucky or unlucky, one or more of these will go short circuit. That can be easy to fix, but then you have the matter of actually finding out which ones it wasn't. That can be a bit tricky as well. But we'll look at that possibility later. So that's the end of that video, guys. I hope you enjoyed that, and I hope I managed to teach you something about these graphics cards that will be very useful to you in future. I can't do anything much more with these now. I'm going to go on the forum. We can't say anything wrong with them, and I'm going to go on one of the, well, I know exactly which forum I'm going to go on, and I'm going to ask the guys, is it possible at all to test a Mac graphics card, if that's what it is, in a PC? Okay guys, that's enough for today, and we can chat